Hello everyone, we want to turn the corner and start talking about the opposite of the derivative or the antiderivative. But before we do that, I want to talk about how we take the derivative for power rules. So I give us an example. If we have f of x equals 3x to the 7th power, then our derivative f prime of x is going to be, of course, you pull out the coefficient. So then the main part is that you bring the 7 down and then you subtract 1 from that 7, which is 6, right? So 7 minus 1, if I were to write it out the long way, right? So if we were to take this into consideration, I guess the first thing you would say is the pull out coefficient. And then here's step 2 here, right, is to multiply by the power. And then here's step 3 here, is to subtract 1. From the power. Right? So the main part about this derivative is to multiply by the power and then subtract 1 from the power. That deals with the x. So that's what I'm going to focus on. All right. If we were to simplify this, then we could say that if we start off with f of x equals 3x to the 7th power, then its derivative, f prime of x, would equal 21x to the 6th power. All right, so the question now isn't how you go from your original function to its derivative, but rather how you start with your derivative and go to your original function. So let me write it this way. In order to go down from f to f prime, you're taking a derivative. But if we were to go the other way, we'd be taking an anti-derivative. Right? The opposite of the derivative. So if, God forbid, you were to consider the derivative a disease, then the antiderivative would be the antidote, getting you back to health, or what you originally started off with. Okay, so it would make sense that these two would somehow be related to each other in the power rule. They should be, you would have to perform the opposite process as what you see here, right? So when you take the antiderivative, yes, you are going to take these into consideration, but with the exception of pulling out the coefficient, whatever's in front, you're going to do the opposite of these two steps. These two are the ones that you have to focus on, right? Because this is just pulling out a number. All right, so let me think about that. So if I want to take the antiderivative of 21x to the 6th power, right? I'm down here, right? How might I do that? All right, let me show you the antiderivative notation. So this is the integral dx. These two are a pair, and we're trying to find the antiderivative of 21x to the 6th power. Okay, now I'm not going to explain what these two are for a little bit, so just be patient with me and know that they do represent the antiderivative. Okay, so what are we going to do? We're going to go back up here and we're going to say, wait a minute, what did we do when we took the derivative? Okay, so the very first thing that you're going to do is, it's going to be the same thing as what you did here. You'll pull out your coefficient, but the other two are going to be different. Okay, so the very first thing I'm going to do is I'll say, I want to pull the 21 out. Okay, so the very first one is you'll pull out your coefficient. But since I'm doing the antiderivative, the opposite of the derivative, I'm going to do the opposite steps of what I see here and in the opposite order. So instead of looking at this one, I'll start with the one where you subtract 1 from the power. And so the next thing that I'll do is I'm going to add 1 to the power. So this is going to be x to the 6 plus 1. Okay, notice I had a power of 6 in here. I'm taking the antiderivative, so I'm adding 1. And then the next thing I'm going to do is, instead of multiplying by the power, I'm going to divide by the power. So divide by the new power. So up here, I'm going to divide by this new power, 6 plus 1, plus c. Now I'm going to keep adding the c, and I'm not going to tell you what it is for a little bit, so just bear with me. Okay, I promise I will clean up the terminology and notation in the near future, but be patient, please. All right, so let's see if we got back where we started. All right, so again, we took the derivative of f of x equals 3x to the 7th, and we got to 21x to the 6th. I'm arguing that we can go backwards by going in the opposite direction with these two steps, right? Okay, so technically opposite of these two, right? That's how we got there. Okay, so let's see if it works. So this equals 21x to the 7th over 7 plus c. Let me go down here. I'm running out of space. So I'll write it all on one line. The integral of 21x to the 6th dx equals 21x to the 7th over 7 plus c, which equals 3x to the 7 plus c. So with the exception of the c, you'll notice I'm back where I started. Okay, I want to show you that together so that you can see what occurred. Okay, look, in order to go from f to f prime, that was the derivative, but I said start here and work your way back up to your original one. Okay, the only difference between this and this is that plus c that's at the end. Technically this has plus 0 at the end, but you'll find out in your near future that c could be a variety of terms, so I have to be careful on how I label it. All right, let's try another one. Okay, so what if we start off with g of x equals 10x to the 5th power. All right, in order to take the derivative, g prime of x equals 10, I'll do it one step at a time, 5x to the 5 minus 1. So this is what? 50x to the 4th power, right? In order to go this way, I took a derivative. Hold on. Deriv, right? But I want to now be able to go the opposite direction, right? So I'd like to go this way, right? From the derivative back to the original function, and in order to do that, I'm going to take an anti-derivative, right? So let's try it. So I'm going to take the anti-derivative of g prime of x, or I'll take the anti-derivative of 50x to the 4th power, right? So let me write both of those down so that you can see it. This is the integral of g prime of x dx, that is the notation, and then here, same thing as the integral of 50x to the 4th power dx. Okay? So let's get to it. So if I take the antiderivative of 50x to the 4th power dx, then you have to remember the steps that we have to take in order to get there. Okay, step 1 is you'll pull out the coefficient. Okay, so just with the derivative, with the antiderivative, you also pull out the coefficient. Because you want to get to the meaty part, you want to get here, right? You want to get to the x to the 4th and operate on that. Oops, this is step 2. All right, so let me remind you, back here, we're going to do the opposite of these two steps and in the opposite order. So this is 2, 3, I'm going to do 3, 2. So I'm going to do here, this one. So instead of subtracting, I'm going to add. So I'm going to add 1 to the power. So this becomes x to the 4 plus 1. Okay, let me show you this again. And instead of multiplying by the power, I'm going to divide by the new power. So here, divide by the new power. Okay, so all of that divided by 4 plus 1, like that. All right, plus C, and I promise you I'll tell you what the C comes from, what the C represents, just not now. So 50x to the 5 over 5 plus C, which equals 10x to the 5th plus C. All right, let's backtrack because we have to ask ourselves, well, what were we going for? Okay, remember, we started off with 10x to the 5th. We took the derivative, we got 50x to the 4th. So when we take the antiderivative of 50x to the 4th, it should get us back there. Look what happened. There's the antiderivative of 50x to the 4th. Look, with the exception of the C, you do get back where you started. All right, so that's how you take the antiderivative of a power function. Okay, I'll go through some more examples in another video.